The other one is called, what was that built on block cipher? Coinalytics.co?
Coinalytics.
Yeah. So, Coinalytics.co. Alright. I guess you need to request the stuff from them. So what they provide is they connect to a large part of the network and they monitor stuff like what the number of transactions coming in from a certain destination is, how many nodes are connected to the network, what they're doing, how long they were alive, how many coins were sent during this particular epoch, and so on. So they will do analytics on the entire network, and you can do that with the information we provided today. Just binary encode the data that we talked about. You can also create cool websites like bitnodes.io, right? So you can map IPs to countries, and that is really what they're doing. And you can get the version that they're using and document that most of the people are using the latest Bitcoin client or not, what version they're using, how long they were alive. Plus, it's a great resource if you don't know the nodes and you don't have access to an NS lookup, maybe. How many nodes are in a particular country. So for example, right now over here, it says there are about 46% of the Bitcoin nodes are using the latest final build for the Bitcoin core client. And then you can see the distribution here. It's very cool stuff. Like there are some people running it on their dial-ups. They're really big, hardcore Bitcoin fans. Some people are running it out of universities. Yeah, it's cool stuff like this. One of the applications that tries to move Bitcoin in a good direction. Yes, go ahead.
Why are some of those people not yet upgraded to the latest? Whatever the reasons why they don't.
Sorry, I can't hear you.
Why are like maybe 20 or 30% of the people not yet upgraded to the latest client?
The question is, why are some of these people not updated to the latest client? Well, they might just be lazy. I don't know. It's analytics. You can do with them whatever you want. Yeah, some of them are just lazy. As long as their version of their wallets are not broken, they're not really going to upgrade. They don't feel the need to, even though the new clients introduce new rules that are probably better for your wallet than older clients, right?
Because it's manual, right? There's no automated. It's manual, right? Somebody has to make the decision to log in and upgrade.
So the comment is it's manual upgrading your Bitcoin client. Well, sometimes it's manual, sometimes you get it from a repository. For example, on Ubuntu, you will have auto updates set up, and you can just update the Bitcoin client automatically whenever the change occurs. You don't want to do it automatically because sometimes stuff breaks, but that's another thing. All right, the third thing I'm going to talk about, a cool application of connecting to the raw Bitcoin network is confidence rating. So for example, if you're in a retail setting and you want to buy a coffee from a barista, right? And are you going to wait for 10 minutes for a confirmation to come through? What if they want 3 confirmations or 6 confirmations? Some people don't want to do that. Some people do not understand that the confirmations are actually necessary. The Bitcoin network was built for the problem of solving the double spends. Some people want it to be very instant, and the way they want to do that is through confidence ratings. So when a new transaction goes into the network, they want to say, hey, so the Bitcoin network was preventing double spends, right? So what we're saying is, if I send coins to Robert, I can also send coins to Shri. Now, what if there was another way to guard against this double spend problem? So I would know when Atif tries to double spend the coins, and when he does do that, his confidence rating goes from 100% to a 0, right? A little risky because you don't know which of those transactions will get confirmed. You know, the miner might decide to pick up the transaction that I sent to Sri, even though I sent it to Chris first. So that's a little risky, but some people want stuff like that. So if you go to, for example, chain.so, and you click on a new transaction that comes in, so it will say the confidence rating has gone. This is updating live. So we connected to a network in real time, and this is getting updated in real time. So we are connected to a very large part of the network. And the idea behind confidence ratings is when you connect to the network and you transmit something like a transaction to the entire network. If most of the nodes receive your transaction first, when you try to do a double spend, they'll be like, hey, those outputs are already spent. Why are you trying to spend them again? So they're going to discard that transaction, and because of that, they will not send an inventory message out saying, hey, I got this new transaction. Does anyone else want it? They'll discard the transaction and not tell anyone about it.
Even though it's not confirmed yet, or it has been?
No. So the comment is has been confirmed. Well, the idea it hasn't been confirmed. It's a new transaction that is raw in the network. It is waiting for miners to mine it, right? So that's what you're using these confidence ratings for. So as long as most of the network knows about this transaction, the idea is no one is gonna mine a double spending transaction. That's confidence ratings. That's an application of what we just talked about.
So Atif,
yes.
I heard about this service a while ago. It's a bit bogus. I'm not sure. I don't think it 100% works, but sometimes it does. And what it is if someone steals your coins and you see it happen, you can stop it. You can stop that transaction from going through by flooding the network with other transactions that sort of double spend that theft. But if the node discards those double spend transactions, how does that work? Because will it always discard the later ones? Why doesn't it discard all of them, for example?
That's an interesting point. So the question is, there are rumors about me canceling a transaction or anyone being able to cancel a transaction after it goes into the network. I don't know how valid those are. I really don't. I can read up on it, but from just what you're saying, I don't know why you would discard a valid transaction if it gets double spends. Some people might want to do that. Again, the Bitcoin protocol doesn't have specific rules for this that are hard-coded into the cryptographic nature of the protocol. So you can do whatever you want with instances like this, right? So I can, yes, go ahead.
Yeah, so just to maybe clarify a little bit, you can't discard them all, because then you open yourself to an attack where you can try to double spend every single transaction, and all the transactions are going to be discarded everywhere, so the whole network can attack. So the first one is pretty safe. The chances of double spending is really hard. You need to react really fast because network propagation for most transactions, especially the small ones, is also really fast. So in practice, it's a pretty hard attack to pull off. So to cancel any single transaction, you actually need to be pretty sophisticated, and even then, you will be spending more money trying to cancel that transaction than just by doing that attack than not doing it.
There you go. Sounds like Matthew. Is it Matthew or Mathal?
Matthew.
Matthew. Sounds like Matthew has some experience with it. So that's all we wanted to talk about. So any questions on what we talked about today? Yes.
The conference rating, is that something you calculated based on the data in the network, or is this part of it is? Like, did you calculate those conference ratings based on whatever algorithm or historical transaction history you?
So the question is, did I calculate the confidence rating, or did chain.so calculate the confidence rating? Yes, chain.so independently calculated this confidence rating. You are trusting chain.so to give you the right information. So what it's doing is it's connecting to a very large part of the network, and it is waiting for all of them to send it inventory messages. Remember, when typically on the Bitcoin network, when you send an inventory message for a transaction, you do it after you've validated the transaction. Okay? You don't do it before you validated the transaction, because you want other people to trust you, right? So if you start it, you send inventory messages for transactions that you like or know that are or think that are valid, right? So the idea is if most of the network, which is, we connected to maybe 500 nodes in there, if 500 of those nodes agree that this transaction is valid, we will give you a confidence rating of 99%. Because what if there were a couple of miners that didn't actually transact or broadcast this transaction and just mined it by themselves, and that was the next block in the blockchain? Like, there's a 1% probability that it might happen, or lower probability than that might happen, and that's why this metric is not completely reliable, but it's something to go off if all you're doing is a $2 or $3 coffee transaction. I think BlockCypher does the same thing with their confidence ratings.
But I'm guessing, I mean, this is not a standardized metric. It's not a standardized algorithm for what the confidence means. So if it might be that the BlockCypher has something they call a confidence metric, and yours something you call a confidence metric, but they have different algorithms. They would mean effectively different things. Is that right?
The comment is, if the confidence ratings, they're just a name without a specification. And many people can call it the same thing, but we're actually doing different things. Yes, that is true. So the first one to come up with this idea, I think, was the Mycelium wallet. And what they wanted to do was, if you were doing trades on the Mycelium wallet, the wallet you get on Android and iOS. So if you were doing local trades through the wallet, people needed to know that the transaction there was a high probability the transaction would go through. And the way they would do that would be the same thing: connect to the network, wait for people to tell them that this transaction is valid, and if most of the network agrees, then this transaction, give them a confidence rating in it. It's not a confirmation, it's a confidence rating. But yes, that's you're trusting the service.
Is there any work put into standardizing the confidence? So that, if you get a confidence metric from one person, you can have some talk that it means the same thing as somebody else. I mean, it's hard if they're different. I mean, you can just trust that both of them mean, that 90% confidence is really good. I guess maybe that's good enough.
or is just number of confirmations a better metric for confidence, right? Because that Bitcoin network itself would tell you there's three confirmations that this made it into blockchain, and that's
right. So the comment is, you need to come up with a specification. Otherwise, you're just going with whatever people say. For example, I could just not even connect to the network and give you, say, hey, good confidence in this transaction, and it was actually double spend, right? So, and the second comment is, confirmations would be a better metric. Yes, confirmations this is not a replacement for confirmations. The thing is, it takes a while to get those confirmations. While this thing, like these transactions are coming in right now, right? Like, click on them, and that's in real time. That's the network agreeing that this transaction is valid in real time. So it just went from nothing to 99% in less than 10 seconds, right? In a retail setting, you will want to use this compared to 3 confirmations, right? I remember when retail shops started accepting Bitcoin for the first time, they were having people wait 30 minutes or 60 minutes before they gave them food. And if you were done before 60 minutes, you had to wait for those confirmations to come in. We've come a long way since then, because we've started trusting one confirmation, which is not really a good idea, but we're looking for something like this.
So just to be clear, in your case, have you published what your confidence metric means so that other people can verify? They could, you need to have confidence in your confidence metric. So one way to do that would be to publish how you calculate it.
Right, so we don't have exactly formulae over here. let's see, get confidence, yes. So we just talk about whatever you see over here is what we really say about this confidence. There is no mathematical formulation of it. I feel there's an academic paper coming.
Well, I don't know, I mean, maybe it's simple enough. I mean, maybe if I just read this, maybe it's really straightforward the way that you calculate the confidence, and there's not anything really sophisticated.
So just to give you some more perspective on what the confidence rating is, so we know the confidence rating, as soon as we detect a double spend on the network, the confidence rating goes from whatever it is to 0, because we have detected a double spend and we cannot be sure which transaction is going to get validated, right? Because a miner might choose to validate the double spend. They can do whatever they want, right? We see double spends occur about 30 to 40 times a day on the Bitcoin network. On the Dogecoin network, we see them about 6 to 12 times a day. That is not a probability of what's going to happen in the future, but that is a perspective to go off of. So when we say that there is a margin of error of 1% in our rating, it's actually a lot lower than this given historical precedent, but we don't know what it might be tomorrow. Everyone might start double spending tomorrow. So it's something to consider.
When you say double spends, you mean person A was supposed to get it, but person B actually got it before person A got it, but person A thought they were going to get it. Okay. So not a double spend, just the person receiving. Yeah.
Right. So the comment is, it's not, when I say double spend, I don't actually mean the blockchain confirms the funds were spent to 2 people when they were actually supposed to be spent to 1. Yeah, that's something. I'm just saying attempted double spend, rather than there's nothing as confirmed double spend,
Right.
because that's what the blockchain guards against. Yes, go ahead.
Something to point out, if you're making a service that walks the entire Bitcoin network, connecting to every node, Bitcoin full node connection slots can be somewhat of a scarce resource these days. So the polite thing to do is, if your company or whatever is doing that, simply set up a second full node and open as many connection slots up to the world for public use as you've consumed in your service. And then everybody will still be sure to have connection slots.
Right, so the comment is number of connections a node can accept, or number of nodes it can connect to is a scarce resource, use it wisely. The Bitcoin protocol, the Bitcoin core client especially, it's built to be able to do well with 10 to 15 connections. You don't really need too much more than that. Don't try to destroy the decentralized nature of the Bitcoin network. We're not connecting to the entire network when we calculate this confidence rating. And the reason we're not doing that is we don't want to destroy the decentralized nature. Even though this node is just listening, it's not actually transmitting data. You can create a listener of your own, and I highly encourage you to do that. You can come up with novel solutions like this that may turn into a business someday for you. Yes, the other question.
Well, I think my question was around the double spend transactions. Are they, is there a lot of fraud? Are they a lot of intentional, or is it just those? No, the reason I ask it.
The comment is, double spends, are they fraud, or are they faulty wallet software or something?
Yeah, and the reason I ask is because if the system doesn't allow double spends to happen anyway, after a while, whoever tries to propagate it will kind of. Okay.
People could just be testing. I know I would poke the box, see what comes out. Yeah. Yes, Steve.
Oh, does it often happen that you see a transaction come through, but it never makes it into a block?
So the question is, a transaction comes through and it never makes it into a block. Does that happen? Yes, it happens. Especially when people don't pay fees. Those transactions, they tend to languish in the memory pool and then eventually get discarded by all the miners, because more valuable transactions that were actually paying fees came through.
So then, if you check for a fee, then you might be acceptable to count that. because you know it's going to go through, but it doesn't have a fee, then you might not.
Right. So the comment is in the confidence rating, for example. I assume that's what, yeah. In the confidence rating, you would take that into consideration. Is it paying the right amount of fee, right? Yeah. So we do that over here. So if you go to a zero fee transaction, you will see. It's good that you're thinking like this. Like there are some protocol specific metrics or Bitcoin core specific metrics that you can leverage to come up with confidence in a transaction. Yeah, definitely, highly encouraged. Just keep in mind the rules might change tomorrow. So your implementation, unless it's updated through Git with the C or reference, it'll need to be changed.
Thanks.
Sure. Yes.
When you join a node as a listener, when you connect to a node as a listener to receive, messages from it, like, for your processing, do you know if you join a multicast address so that node can send that data out on multicast, IP multicast? Because that will reduce the bandwidth requirement substantially.
So the comment is, when you are propagating data on the network, can you just do it over multicast? Because that reduces the bandwidth. You could. I don't see why not. As long as that multicast connection is reliable and you can receive data on it, or maybe establish two connections, one for transmitting and one for receiving. Yeah, definitely, go for it.
No, but I mean, I'm wondering if the Bitcoin client, because everybody is running Bitcoin, because this would be a big, make it very easy for a lot of people to listen to any given node.
Right, the Bitcoin Core client may not do this. I haven't explicitly explored this, but the code is there. All you need to do is check. Yeah, that's maybe a good solution for bandwidth concerns. Looks good. Thank you.
Well, thanks to you. Atif, Nazir, Block.io, fantastic instructor, huh? Man, you guys have got the best. And another good one coming up too. Thanks again, Atif. So we'd like to welcome a few new students and a guest. So Stephen and Rashil, Brad, Reese, could you all come up here? And a big shout out to Rich Bodo for bringing these wonderful power strips. So thanks, Rich Bodo and Singularity University. So we have Reese Fowler here from Coin Beyond from up north. Tell us about yourself. 30 seconds, guys.
Sure. So my name is Reese Fowler, and I'm with Coin Beyond, one of the co-founders. We are based north of Seattle, and our company is focused on bringing Bitcoin into the early majority segment of the market. So essentially, if you're wanting to head up Castro Street, buy lunch or whatever, our point-of-sale system is what you would be using, hopefully. It's very similar to the Square payment system. We not only accept Bitcoin through our system, but also credit and debit. Our lead developer does a lot of work with HDM wallets. We have that integration coming along. If you want to check out our website, it's coinbeyond.com. Right now we've released our MVP on the Android App Store, and we'll be on iOS here soon. So I'm also, I guess, working on bringing more development opportunities up